Hi my friends, today we model this part, valve lid, which is not so difficult, but there are some problems as always. As you can see, there is a cut here, yes, a revolution cut, and of course relatively complicated this contour, but there are not so difficult problems. Let's see the drawing. You see dimensions. This is the cut I mentioned, here and here, and the contour which must be created in respect of these dimensions. Let's start. New standard IPT, plane XY, and we draw some lines, as you can see here, and another line and an arc. This arc has the center on the vertical of the center point. Dimension is a diameter of 55. A dimension here of 14.5, and a radius of 68. Oh, it finished somewhere here, because this is 12.5, fully constrained. Finish sketch, F6, revolve. Okay, now this was this revolving object with the radius 68, dimension 12.5, 14.5. Good. Let's create this contour together with this one, because they are on the same plane, external, not internal. So we create this plane, which is placed at 28 plus twice 10, which is 48. Yes, so this dimension is 24. What about this? This is 32, 40, 48. Yes, this dimension is 48 on both sides. Okay, let's create this plane from the XY plane. Plane starting from XY plane to the back, minus 28 plus twice multiplied with 10 divided by 2. This is the plane. We create a sketch here, F7, project geometry, this face and this face. Then we draw lines from here. Once again, we draw lines from a point on this line, an arc, and then with a tangent to this line. I go to the center and then to the right up, an arc. You can take a look at the drawing. Tangent, vertical, a small arc here, another line, tangent, not parallel to anything, an arc, a vertical, horizontal, no parallel, no perpendicular. Now it is perpendicular. I don't want to be perpendicular. I click here, I click on the constraint and I erase the constraint to have this freedom. Yes. Now I continue from this point with the line not parallel, not perpendicular, tangent, and I go here and I connect these 2 points. Okay, this line must be, oh, this is not good. I erase this and I draw again a line between these 2 points. Okay, tangent, these 2, the other are all tangent, and I start with placing on the same vertical this point with this point, but they are not well positioned. Let me move them like this. I place here a radius of 10, as in the drawing, of course. 20. I move this point so this must be horizontal and this vertical. This is to be below the face at a distance of 1.5. Now I place on the same vertical this point with this point. Angles 30 degrees is this, 20 degrees is this, 70 here, and distance is 58 is from this end to the center point. 58. 36 is either this point or this point because they are on the same vertical from the center point. 36. This point is placed at 5.5 here. The radius is 4.5 and I don't like 160. I delete it and I place 20 because this is the dimension in the drawing, 20. Good. This is 5.5. The distance here is 3.5. I know dimensions because I try to make a very good sketch here. This radius is 5. This is 2. And there is a dimension between this point and this face of 13.5, which is not accepted, but we make some changes around. Let's see why it is not possible. I move this point or this center. The center must be placed at 2 millimeters from the face. 2 millimeters from the face. Good. This is a distance from here to this point of 23. Good. Now there are many dimensions missing, but I didn't place no dimension here. This circle is at 1.5, radius 7.5, and the distance is between these 2 points is 22, and the distance up is 26.5. But let me place this dimension before, which is 35. From this point to this dimension, from this point to the center point is 35, but it is not accepted. Why? Why do you think is not accepted? Because this is parallel with this. I didn't, or with some other. Let me see which line. This is parallel with this. I don't like this. I don't want. I delete the constraint, and now I can place that distance here of 35, and this is 26.5. Okay, 3 dimensions needed. I don't like 160, and I place again 20 here. The supplement here, and let me see what happens with the last dimension. Oh, this point with this point are at 13.5. Yes. Now we have 2 dimensions needed. One of them is this point at 18, and the other is the placement of this arc to the right, parallel with this, to place a dimension here. What dimension? 14. This is the last. But now I have some other problem. Oh yes, this is not 18, this is a result. So I apply 14 here. You see, there are some problems with this sketch. Now it's fully constrained. This is what we want to have. I make this to be more legible. I move some dimensions only for aspect to have a nice sketch. Yes, when you look back to your work, you have to see something legible, not agglomerated or overlapping or other problems. Everything must be clear for you or for your friend in Australia, which is in cooperation with you to create this project. Australia, not Australia, Papua New Guinea, New Guinea. Yes. Okay, finished sketch. Now we take a look to the drawing. 8 millimeters is here, and 10 minus 1 is the other dimension, because there is a boss of 1 millimeter, which is this one. Yes, you see, 1 millimeter. This is 9 and this is 8, but the face in the back is the same. So I apply extrude of 8. I create an hide the plane. I create a new sketch here. The sketch is ready. Finish sketch. Extrude 1 millimeter. Okay. Now I want to create this to 32 and 28 plus 1 is 30, the distance here, because I want to have 26.5 face here. It is not the circle, the cylinder, but a face. Yes, this is a chamfer of 5 at 45. So let's create these cuts, but we don't have the other end. We'll mirror after we create the boss. So this is the plane where we create F7, 2 rectangles. This is one and this is one. They are not aligned, not nothing. We align them by placing on the same horizontal the midpoint of the left one with the center point, and the midpoint of the right one with the same center point. Now we project faces, this one and this one, and we make collinear this side with this side with this side. Yes, now I'm sure that they are okay, considering the symmetry about this axis. Now 26.5, 26.5 on the left and 26.5 on the right. These are dimensions in the drawing. We respect them. Then I apply coincident of this line with this endpoint. Also this line with this endpoint, because I don't want to place a dimension. Yes. Finish sketch. Extrude 1, 2, symmetrical, cut all the way. Okay, then I make this. No, let me create the mirroring. Mirror of this extrusion and this extrusion about the XY plane. Okay. Now I select this face, F7, I project geometry, this line and this line, I make everything construction, and I create a rectangle between this endpoint to this endpoint. Finish sketch. Extrude. I want to eliminate this gap. Yes. Extrude this face to the part. Not cut, but join. And I add this missing material. Okay. The same on the other face, but let me apply here the chamfer of 5, because we discussed about 5. Okay. Good. Same on this face. Sketch, F7, project this and this, everything construction, and a rectangle from this point to this point. Finish sketch. Extrude face to the part, not cut but join. Okay. F6. Now we create bosses, which is this face, where we simply add a circle. Extrude this 1 millimeter, like before. Okay. Then mirror this last feature about XY plane. Okay, now there are two bosses. A hole of 7 is through all. And then look here, we have to create this internal volume with this channel. Yes. So we'll respect these dimensions. You have them here. Good. Hole, this face, this center, diameter of 7 is selected and through all. Okay. F6. Now we select this plane, XY, F7, and we draw half of the contour. We start from here to somewhere with an arc. The arc is placed on the same vertical with the center point. Its center with the center point, its end with the center point on the same vertical. Now we project this geometry and we make it construction because we don't want to participate in generating the next feature, and we select, we make them concentric, this with this. Yes, to be concentric, but at another radius, of course. What radius? 63. Good. This point is to be somewhere here, and we draw a line. A horizontal, an angled, sloped line, but now it is perpendicular on some other. I don't want, oh, these two are perpendicular, notice. I continue with a line like this. Another line is at an angle, and we end with a small line here, another one to the center, and another one center line. Yes. Good. This angle is 90 or perpendicular, this with this. This is 45 degrees because it is a chamfer, in fact, with a height of 1. This distance aligned is 4 millimeters, and this one aligned is 6 millimeters. This is 3. This is a diameter of 30. There is a radius of 2 between this and the vertical, an angle of 15 degrees, 15 here, and an angle of 70 degrees here, 70, and the diameter of 44 between this point and this axis. 44. That's all. Fully constrained. Finish sketch, revolve, cut. We want to create a hollow here. Okay, that's good. Now all we have to add is this cut 52 at 10 degrees, which is placed on this face. Yes, on this face here. It cuts very small parts from our part, but it must be placed. Okay, we use the same plane. We can use any plane with which contains this vertical axis, F7, and we draw one line to somewhere, another one here, here, and we close with a center line. 52 is this dimension. 52, and this angle is 90 plus 10, and the drawing is 10. We make something. I don't want to place distances, but I select this arc to make tangent this line to that arc. If the designer changes something here, this dimension will be changed as well. Finish sketch, revolve, cut. You see what is here. And now we apply cut. Okay, and there are some small cuts on the contour, but I don't see these cuts. Where are they? Yes, here is a cut. Must be. 22 was placed here. I wonder. Let me see. This was the extrusion. 22 is here. So why that problem? You see, here is a cut in this part. Let's measure M from Monaco. This is 29. Oh, not 52 is there. Yes, it is 58. Let's change. There is a mistake here. This is not a good dimension, and I'll change the drawing. So this is a parametric design, when you can change dimensions. 58. Now it is okay. Yes, the original drawing is with 58 here. this is why this cut is present. Good. The last things to do are these fillets. Radius 2 all over. Where? On this contour and below. And also here. Select this. Radius 2 is by default. Also the opposite, and also below here and here. Okay, F6. That's the part, my friends. Let's apply material. Steel cast, general aspect steel cast, some faces to be machined. This I keep pressed the shift button when I select the face. This, and also here these faces are machined to be precise. You'll see in the next tutorial that this object and the one in the previous, I apply here steel polished. This object with the one in the previous tutorial 175 and the next one in the tutorial 177 will create an assembly, and they work together very nice. I'll show you in the next, at the end of the next tutorial. Wait for me. What is the data? Update, and there is here all you want to verify if you created a right part. I made the correction to the drawing, so now this is the actual value, 58, not 52. So this is the final drawing with all dimensions okay. That's all for today. Thanks for watching. Bye bye.